Have you ever wondered how far our understanding of numbers goes? How big can a number get? This is the unfathomable concept of big numbers. They are not just about counting or measuring, but they are also a testament to our human capacity for comprehension. Our fascination with big numbers is not new. It's as old as civilization itself, embedded in our DNA. This fascination has led to groundbreaking advancements in various fields. In mathematics, it's given birth to concepts like infinity. In technology, it has enabled us to process vast amounts of information. And in philosophy, it's prompted us to question the very nature of existence and infinity. Big numbers are more than just symbols on a page. They represent our collective desire to explore, understand, and ultimately transcend our limitations. They're a testament to our curiosity, our ambition, and our relentless pursuit of knowledge. As humans, we have always been curious about the vastness of numbers, pushing the boundaries of what we can comprehend. The journey of big numbers has a rich history. Our story begins in the time of ancient civilizations. The Sumerians, Egyptians, and Greeks, and many other cultures all had their own ways of dealing with numbers. But back then, the concept of big numbers was relatively simple. They used a tally-like system, where each mark represented a unit. The more units, the bigger the number. But as civilizations grew and economies became more complex, so did the need for bigger numbers. The ancient Romans, for example, developed a numeral system that could represent numbers up to 1,000,000. Yet this system was still restrictive, as it was difficult to perform mathematical operations on these numbers. Then came a pivotal moment in the history of big numbers, the invention of zero. This concept, first developed by the ancient Indians and later adopted by the Arabs, revolutionized the world of numbers. Zero was more than just a placeholder. It was a symbol that allowed us to conceptualize the absence of quantity, and it paved the way for the development of our modern number system. The invention of the decimal system was another significant milestone. Introduced by mathematicians in India and the Middle East, this system was a game changer. It simplified calculations and made it possible to represent really big numbers in a concise way. The decimal system was later adopted by Europe during the Middle Ages, and it's the system we use today. In the centuries that followed, the concept of big numbers continued to evolve. Mathematicians began to explore the world of infinity, introducing numbers so big that they're beyond our comprehension. From the Google, a 1 followed by 100 zeros, to the Googleplex, a number so large that there's not enough space in the universe to write it out. From simple counting systems to complex mathematical concepts, the history of big numbers is truly fascinating. And we're still on this journey as we continue to push the boundaries of what we can comprehend and quantify. Now, let's dive into the world of the biggest numbers. Imagine a number so large that there isn't enough space in the observable universe to write it down. There are such behemoths in the realm of mathematics, and these are the titans we're exploring now. First up is a Google. Not to be confused with the tech giant Google, a Google is a 1 followed by 100 zeros. The name Google was coined by a 9-year-old, the nephew of mathematician Edward Kasner, who was asked to think of a name for a very big number. A Google, though vastly large, can still be written down. It's used to illustrate the difference between an unimaginably large number and infinity. Then, we have a Googleplex. A Googleplex is a 1 followed by a Google number of zeros. The sheer size of a Googleplex is mind-boggling. It's so large that it's impossible to write down, as there isn't enough room in the observable universe to accommodate all those zeros. However, the crown for the largest number ever used in a mathematical proof goes to Graham's number. Named after Ronald Graham, this number is so large that conventional notation can't express it. It's used in the solution to a problem in the field of Ramsey theory, an area of combinatorics, a branch of mathematics. Graham's number is so immense that even thinking about its size could theoretically create a black hole in your brain due to information density. These numbers aren't just theoretical musings. They have practical applications in areas like cryptography, statistical mechanics, and computer science. They help us understand the scale of the universe, the complexity of networks, and the limits of computation. These numbers are so large they boggle the mind, showing us the limitless possibilities of the numerical world. The dance of these giants across the vast stage of mathematics reminds us that even in the realm of the infinite, there's always room for something bigger. But what role do these big numbers play in our everyday lives? Big numbers, believe it or not, are woven into the fabric of our modern world. They're integral in computer science, helping our machines process vast amounts of data. Think about the billions of calculations your computer performs every second, or the trillions of bytes of data streamed across the globe daily. In the realm of cryptography, big numbers are the guardians of our digital world. They form the backbone of encryption algorithms that secure our online transactions, protect our private communications, and safeguard our most sensitive data. Venture into the world of quantum physics, and you'll find big numbers helping us unravel the mysteries of the universe. They're used to calculate the probabilities of quantum states, shedding light on phenomena that are beyond our everyday experience. Indeed, big numbers are not just abstract concepts, but tools that shape our understanding of the world. What does the future hold for these gigantic numbers? A question that sparks as much intrigue as the numbers themselves. As we venture further into the realm of the unknown, the role of these colossal figures becomes increasingly significant. In the future, big numbers could play an even more fundamental role in our daily lives and scientific advancements. Imagine the scope of data analysis or quantum computing, where big numbers could redefine the boundaries of what's possible. The opportunities are limitless. However, the future of big numbers isn't without its challenges. Just as these numbers push the limits of comprehension, they also strain our mathematical tools and systems. Developing new ways to handle, represent, and make sense of these behemoths is a task that future mathematicians and scientists will grapple with. Yet, this challenge is also an opportunity. It's a call to innovate, to create, and to discover. It's an invitation to redefine what we consider big and to expand our understanding of the universe. The journey of big numbers is far from over. As we continue to push the boundaries of our understanding, who knows what incredible discoveries await us?